So this is my video report of the Unit 7, 7.3 and 4. Firstly, I set a question about the slope field to be an introduction for students. And then I make an example and tell them and remind them need to pay attention to different ranges in the slope field. And then I make some special points, and then according to these points to draw the final graph. Then I told them the definition about the slope field and gives the steps of how to draw it. And then I make some examples. And later I will detail to explain how to solve them. Let's begin to talk about the example questions of Unit 7.3 and 4. The first question is about the 7.3, how do you sketch the slope field? So the first question, we need to identify which of the following differential equation satisfy the graph above. And firstly, we can find the two special slope. It's about the when x equals 1 or the y equals 0. And we need to plug them into the following equation of the slope to identify whether they satisfy the condition or not. So firstly, we can plug y equals 0 into the option A's equation. And when y equals 0, dy over dx equals 0. When x equals 1, dy over dx equals 0. So it satisfies the condition and the graph above. And then the option B, we need to simplify it first. And also the same step as the option A. If y equals 0, dy over dx equals 0. If x equals 1, dy over dx equals 2y. So it's not 0 unless y equals 0. So B is wrong. And option C. Also, firstly, we need to simplify it. If y equals 0, dy over dx equals x. It's not 0. So it's also wrong unless x equals 0. About option D, and if y equals 0, dy over dx equals 0. If x equals 0. But I need to remind you guys, look at the graph above. If x equals 2, y equals 1. But when x equals 2, for this part, y is not the positive. So the D option is wrong. Doesn't match the graph above. And about option E, if y equals 0, dy over dx is not 0 unless x is 1. So in general, we can find A is the correct option. So we will choose the A. Okay, let's go into the next part. It's the 7.4's question. Which of the following should be a solution to the differential equation with the initial condition y2 equals 0? So firstly, we need to plug x equals 2 into the different equations above to identify if the result equals 0. Okay, A, when x equals 2, y2 equals 0. B, when x equals 2, y2 equals negative 2 over 3. C, when x equals 2, y2 equals line 1 equals 0. D, when x equals 2, y2 equals negative 2. So we can see about option A and option C, both are 0, but we need to pay more attention about the C. We need to know line 0, it does not exist. It has no meanings. So the final answer is A. Okay, about the last question. Which of the following statements about the solution y equals fx to the differential equation must be false? Option A. About the particular solution, f2 equals negative 2 has a relative minimum at x equals 2. So we can find the point 2, negative 2 in this point. This slope equals 0, so the curve is from the negative to the positive, and there may be have a value. So A is true. And about the option B, the graph of the particular solution satisfies f -1 equals -1 is concave up on the interval -2 to 1. Let's find the points about the -1, this point, we can find that this point of the slope is the negative, so it must be the concave down. So the option B is false. Next one, C. This particular solution that satisfies the f1 equals -2 is linear. Okay, let's find this point. The point is linear because the value of the x doesn't change with the change of the y. So C is right. The last one, the graph of the particular solution that satisfies f-1 equals 2 is concave up on the interval -3 to 3. Let's also find the point. -1, 2, this point. Okay, in this interval, it is increasing. So the correct and the final answer is B.